My name's Karen Kinnear. I'm the JVM runtime lead at Oracle, and I'm going to talk about frontiers of access controls. It's a three-part talk. I'm going to talk about modules and nestmates. And I want to preface this with, I did like John, every slide is way too full. I'm saying far too much. There's no time for questions. So we have two workshops. We have a workshop which Alan Bateman is running tomorrow about modules. So bring your questions there because you'll have a whole lot of people who know even more about it than I do. And I'm giving a workshop on Wednesday for Valhalla value types. And if you have nestmate questions, bring them there. So I wanted to start like Paul did. I thought it was really nice to start with a thank you. So I'm going to do a starter list of folks who worked on nestmates who know far more than, on modules. So Mark Reinhold, Alex Buckley, Alan Bateman, Jonathan Gibbons, Mandy Chung, Paul Sandos, Lois Fulton, Harold Seagal, George Triantafilou, and if I missed you, I apologize. There's a world of people who've worked really hard on this for years. And for nestmates, I want to thank Dan Smith, Bjorn Vardal at IBM, and David Holmes, who's in Australia. So we're far-reaching. You've seen this before. So I'm going to do this in three parts. The first part, I'm going to discuss the JVM access controls in general, just brief review, so we're all speaking the same language. Then I'm going to discuss access controls for modules, which is coming soon in Java SE 9, and then access controls for nestmates, which is a Valhalla work in progress. So don't believe anything I said. It will all change by the time you see it. Okay, so JVM access controls, what are they? This should be familiar to everybody, but just for quick review, access controls, the access control flags come in two parts. We have type access and we have member access control flags, right? So type access, your public or your default, which means package, and member access is public, protected, default, or private. There's a key point to this. In neither of these projects have these flags changed, okay? That's key. There's another key point, which is anytime you want to check member access, you check type access first. The first feature I'm going to discuss, which is modules, has changed how we deal with type access. And the second talk about nestmates has changed how we deal with member access. The flags themselves haven't changed. Oh, one more note. Everything I talk about is talking about runtime types, so any class or type, and I'm going to be really fuzzy about using type and class. So if you're a language person, my apologies. I always mean runtime. If I talk about a package, it's runtime, so it's always paired with a class loader, okay? So this is a talk about how runtime handles these. So where are JVM access controls checked at runtime? Verification, bytecode resolution, which is the common path everybody thinks about. We check them with inheritance and APIs such as method handles, var handles, and reflection. So there will be a quiz at the end on the access control JVMS. This is SE 8, and I'm trying to illustrate it, okay? So here's a picture. I am a auditory, not a visual, so apologies on the pictures, okay? So seriously, it's a struggle for me to have to do this visually, so boxes is the best I could give you. So this is the terminology I use for all my boxes. This is a type access check. In Java SE 8, target type T is accessible to type S if, okay? So see if this will work. You have S is making the access check, the access request. S is in package P sub S. I use that syntax all the way. And then you have type choices. So you have a default T in package P sub T, or you have a public type in package P sub T. And the rules, which you're all familiar with, are if it's a default type, if the packages are the same, the answer is yes. If it's a public type, the answer is yes, always, right? You all know this stuff. So that was easy. So member access check. This is the review without change, right? You all know this one too. Same kind of syntax. Is target member D.X accessible to type S? So once again, we have S in package P of S, and then we have the different member access flags. Public, always protected. This means if S is a subtype of D, where D is the declaring class, okay, of X, or if they're the same package. Default, if they're the same package. Private, if they're the same type, right? So all of this is familiar. Just wanted to put up there so when I change these, you'll notice the difference. Okay, so let's jump into modules. In order to do that, I want to give some background on modules. This is a very quick summary of modules. What is a module? So a module is a named set of packages. It's designed for reuse. We've partitioned the packages into concealed and exported. Confinement, got it? We're doing this. And a module depends on packages exported by other modules explicitly. Clear boundaries. Good parenting, good coding. Type accessibility. In Java SE 8, we had a class contained within a package. Those are our containers. We have class access, because with modules we're just talking about type access, default, and public. Okay, type accessibility with modules in Java SE 9 has changed. We have class, inside package, inside module. Now, you'll notice the class inside package, you got that in your fully qualified name. We did not change that for module. So we need a way to specify that. We also have modified the class access. We did not touch the access for default or package private. We have changed how public is translated, how the accessibility check works when you're in a module, okay? And I will go into gory detail about that. This is just your teaser, okay? How do you define a module? So you define it with a module descriptor. So basically, it's a Java source file called moduleinfo.java. We compile it into moduleinfo.class, which is your module definition, and the class file lives at the top of your jar. This declares your module metadata, because we had to have a place to put that important information, like what packages are in it, like what your module name is, what your requires. These are the two key ones. There's lots of others, and there's a link at the end that you can go find the others. The two key ones for access controls are a module requires another module, and a module exports packages to other modules, okay? So I will repeat that in the next one because it's so important. So, and you can just, sleep tape this. A module requires other modules, and a module exports packages to specific modules or to all. So we have a picture, thanks to Alex Buckley. I stole this from his slides. Let's start with java.base is the basic module for Java SE, okay? Everybody requires java.base, and in fact, you get it for free. The JDK has been modularized into a whole bunch of modules. This is the bottom one. It contains things like Java-like object, which you all need. Java-lang, Java.io, Java.net, there's supposed to be a ... here. Those are the exported packages. And then you have things like security and JDK internal. Those are the concealed packages, okay? In this example, you write your own module, and it is, so in your source directory, you put moduleinfo.java, and you say, I want to write a hello world. I stole this from Brian. So this has a fancy print package, because I had to do a trivial example, that you really want to make available to others, okay? And it also has some internal stuff. So you write your stuff with two packages. com.hello.internal is your package that has all the stuff you don't want to expose. And then you have com.hello.print package, which you export, okay? So how do you do that? You do that in your module info. You give it a name, hello world. Okay, could have been more creative. But anyway, requires java.base. So there's your little arrow from this module to that module, and exports com.hello.print package, okay? So java.base exported these libraries to me, and I export, packages, this package to others. You compile it with Java-C, you compile both the module info and your source, and you run java -n hello world. So, hang on, I have a whole lot more to say. Let me give you the rest of it that didn't fit on the slide, but I'm going to tell you it anyway. So modules are designed explicitly for reuse, okay? Following the principle of the unit of reuse is the unit of release. So you've all been shipping things with jar files. We didn't change that. Keep shipping them with jar files. If you add your moduleinfo.class to the jar file, you have now created a modular jar. And others can reuse this modular jar by writing requires hello world in their module info, okay? And there's a real benefit here. This is the confinement benefit. The releaser, you, hello world, benefit because nobody's going to be using com.hello.internal. And that's access checks. We're going to prevent that, okay? That's what we do for a living. I know, I anthropomorphize the JVM, apologies. And the other piece is that the guy who then does the importing, he benefits because you've committed that the ones that are exported, they aren't going to change on it, okay? So you can explicitly say these are going to be supported and these aren't. And it reduces your burden and it lets them count on you. So this is one of the benefits of confinement. So how do we use this module information, okay? At the beginning of time, when we compile or run a Java program, we perform module resolution. So resolving a module entails resolving all of its dependencies. We start with the observable modules, which come from the module path, which I'll go into later, and from the system image, which I'll touch on later. We start with a set of root modules. So when you did Java -m hello world was your root module, okay? We form a readability graph. So we do a recursive enumeration of all the requires, and we get a readability graph. So this resolution ensures that you have no missing dependencies, no cyclic dependencies, and no module M reads more than one module that exports package P to M. So there's no ambiguity, okay? So one of the things I should do in terms of terminology, you put, I should have put it up there. Hello world requires Java.base. We build a readability graph. So at runtime, accessibility checks readability, can read. So that's the terminology. You wrote requires. We took all the complexity of requires and turned it into a readability graph. So I will use the term read. We touched briefly on where do you find modules. So there's a module path, which is a sequence of locations for modules. Modules have several formats, one of which is an exploded directory with its module info. One is a modular jar. There's some other forms. We talked about, we search the module path when looking for a module. In a fully modular application, if we were starting from scratch, we'd find everything on the module path. Obviously, that's not the world we live in, so we have class path and module path, and we can mix them. The other place we look is in a runtime image. So there's a new tool called JLink. Go play with it. It's really cool. The default system image has the Java SE modules. You can create your own that has and make an executable for just your app with just what you need in it. So I'm pretty excited about that. So class path versus module path. You're all familiar with class path. Let me mention a couple things about it to distinguish how module path, we tried to make your life a little better. So with a class path, I also happen to be a class loader in my other life, okay? When we go to look for classes, we linearly search the class path for at the class granularity. What that means is, A, it takes time, and B, if you have shipped old and new of the same package, and the first class you reference is, let's say you have package P, and it has old class in it and new class in it. And you had already on your class path package P with just old class in it, and since we all of our admins append to class path because, right? You've got them both on your class path right now. So I search for new, and I find the new one, and I'm happy. And then I search for old. And darn if I don't get the earlier one, not the one that's been changed, okay? So you can run into some interesting pain points there. We try to avoid that with module path. So the module path is designed to be predictable. Only one module of a given name is observable. There's no interference. So we perform a directed search. Once the runtime finds a module, it remembers its packages and never has to search for those again. We know where they are, okay? So at the package level, we will find them all in the same place, which gets rid of that mess. It also means that class loading is order of 1 instead of order of n. So for those who've been asking for years, yes, we are making class loading faster. Two-way street. So we're back to that original question. I've given you the module background. That's all I'm going to give you for background. The question is accessibility, right? So can class S access public class T? So you'll be able to draw this in your sleep by the end of this talk. Okay? Class S in package PS in module MS. Can it access class T in package PT in module MT? So the question is type access from this type to that type. So there's two questions you ask. We ask a read question and an export question. Okay? The question is, can module MS read module MT? And does module MT export package PT to module MS? Okay? Have I declared this as a dependency? And did you allow me to get there? okay? So in this particular case, our module MS requires MT. Check, got the reads. Module MT exports PT, okay? Where this means exports to all. So in this case, the answer is yes. But this is the heart of the new access checking, okay? We've set up our module boundaries. We explicitly declare our dependencies. We explicitly export. Access checking checks this at compile time and at runtime, okay? So this is part of the quiz. So this is JVMS 9.544 access control. These are the changes. Let me put them in my picture, okay? So this is exactly the picture you saw before. I'm not even going to go over it again. Note that member accessibility is completely unchanged. We've added a new box. We now have S is in package PS in module MS, and public T is in package PT in module MT. The first thing we do in our job is to work really hard for backward compatibility, okay? So default T is in package PT. This is unchanged. If you're in the same package, you're golden. What we have changed is exactly what I told you in the other slide, is to do access checking S in module MS, T in module MT. First we check reads. Can MS read MT? And second we check, did MT export PT to MS, either explicitly or to all modules? If you pass those, you're golden. Okay, those are the new rules. That's the heart of it. I work in the VM. We tried to ensure that this didn't slow down at all. We have some shortcuts. If you're in the same module, well, duh. If you're in the same package, then you are also always in the same module. Well, the answer is yes. Okay? So I mentioned backward compatibility. What do we do? How do we interoperate with classes that have not declared module information, right? You have thousands of classes, tens of thousands, hundreds of thousands of classes out there on the class path. We coined the term unnamed module. It's analogous to unnamed package. So today, if you write a class and you don't declare a package, you're put in the unnamed package. Okay, if you don't have a module definition, you're in the unnamed module. Okay, and the goal of the unnamed module concept is to allow existing code to work. So we have a couple of rules. The unnamed module can read all other modules. This is easy to remember. Where would you have put the information specifying what you can read? Right, okay. Well, we tried to make this clear, right? An unnamed module exports all packages to all modules. Again, there's no place to declare this, right? So we tried to make that easy. There is one unnamed module per class loader. So for most people, the unnamed module is synonymous with the class path, and that's the hand wave, oh yeah, it's the class path. And for most people, that's all you care about. If you happen to be a person who cares about multiple class loaders, there is actually one for each class loader. So the application class loaders, unnamed module is, we find the classes on the class path. The bootloader, we find it on the boot class path, which only has one flag option left, -x boot class path / append. We are looking there last, no prepend. And JVMTI has an appended boot class path, okay? So let's see what this did to our access checking, okay? I showed you this one earlier. We added some things. This is the last complexity. That's as far as it grows, okay? So we've already talked about the access to a type with a default access is just package membership. So here we have extended, this is in a module, a named module, and this is an example in an unnamed module. So this is unchanged, right? The other piece that you want to notice is if S is in an unnamed module, accessing T in an unnamed module, the answer is always unchanged. All these are unchanged, right? Totally backward compatibility. Now we want interoperability, okay? So the next exercise we did was make sure that you can work between your class path and your module path. So between your named module and your unnamed module. Remember, named module, you check reads, you check exports. Same rule. If I am S in an unnamed module and I want to access T in a named module, well, reads comes for free, and you check exports. And we actually allow you to export to all unnamed, which is a very helpful thing for backward compatibility. Same concept here. If I am S in a named module and I want to access T in an unnamed module, we check reads, same rule, and MT always exports to all modules. So fundamental message, check your reads, check your exports, okay? And We tried to make it as clean as possible so you would work with old code as much as possible. So where do we do the checks? I mentioned that we do type checking and member checking, and that member checking, first you always have to do a type check. We do this in verification, and that's only the special protected handling, so I don't have to go into detail. I will now discuss bytecode resolution, which is the one most people care about, and then the APIs. Bytecode resolution. So here's some sample bytecodes, not complete, that resolve a symbolic type reference in the constant pool. So things like new, instance of, our favorite LDC. They are going to resolve types and therefore do type access checking. That also with get static, get field, put field, we have field descriptors. We have method descriptors with invoke virtual, invoke special, et cetera. So this is my terminology, and this is where I apologize if I could have found a clearer way to write it. This is the language I speak inside the JVM. So if class S wants to do an invoke virtual on a static reference type, member named X, on a dynamic receiver, object ref of receiver, okay? So we're gonna figure out where the access controls happen. So we have this ref C is the symbolic type reference or static reference. X is the member, in this case it's a method. Receiver is the object ref, receiver this. And D is the declaring class of X, which you don't see in here, but which we care about, okay? So let's see what happens. There are 3 steps to method resolution. First, we resolve the static reference. Then we resolve the member, where we start the search starting at the static reference. We look locally, superclasses, maximally specific superclasses. And then we either find the member, name and sig match, or we don't, in which case it's an error. Then we do selection based on the dynamic receiver, okay? So we select the member there. Something that is something we pay close attention to, and hopefully you guys don't need to, is that constant pool resolution requires that we always return the same result, success or failure, including like an illegal access error, which is what your access type checking would give you. So that has generally not been a huge big deal, but one of the things that we've added with modules is you can dynamically augment your readability and your exports. You cannot decrease, but you can increase. This will not help you with a bytecode that has already resolved a constant pool entry, okay? It will not change what we return. We have promised we will always give you the same answer. So do it before you do the reference, okay? It matters. So to add access checking to this, step 1, we resolved the static reference, and we do a type access check. Can S access that resolved type? Then we resolve the member, and we do a member access check. Can S access X as defined in the declaring class? And then selection for invoke virtual, we actually do this up in advance to make it faster. We cache it in our cached selection table, which is our V table or virtual table, and it follows the inheritance and overriding rules. So let me talk just briefly about those. Inheritance and overriding model did not change with Jigsaw, okay, with modules. Inheritance type accessibility has always required that a subtype have type access permission to its direct supertype. That is still the same. However, as we noticed, we are also going to be checking reads and exports, right? So for your direct supertype, you have to be able to access it. That is not new. The extent of the things we check have been extended. Overriding, I won't go into great detail, but fundamentally it means a subtype has to have member access to a supertype's member in order to override it. Just leave it at that. Libraries, so method handles and var handles follow the bytecode resolution or Java language access check rules. So they should behave the same way, doing the type and member access checks. There is an exception, of course, for backward compatibility. There's a public lookup with unconditional mode that ignores reads. One thing to note here is that for performance, with a lookup, we can pre-cache the answer to that check because it's the same guy requesting the same member access. So that's how we make method handles and var handles faster, or one of the ways. Reflection does type and member access checks also. It actually ignores reads because we have so many frameworks we really want to keep working. It does check open. So I talked to you about requires and exports. There's other flags. Opens is one of those. So a package can open to another package. It's analogous to exports. It's explicitly for what's called deep reflection. So it's explicitly to allow set accessible to work. So you can have a package open. You can have an entire module open. And opens implies exports, okay? So for those of you who use that back door of set accessible, which, well, it's very, very useful. It gives people a lot of power, and it messes up all sorts of assumptions about things not changing. So in all the talks we've had today, I kept wanting to raise my hand and say, could you please stop using set accessible? Because people are using back doors to write things that they should not have access to. But anyway, set accessible will fail if the type in a package is not open to the caller. And it actually is a little more complex than that, but we'll summarize there. There's some migration aids. I'm going to just put these up here so that you can read them later. I'm not going to walk through them. The point is we've tried to make things as easy to migrate as possible, and I know there's still challenges. So if you have more questions, go to the workshop tomorrow, okay? And I'm going to jump into Nestmates now because 45 minutes is a really short talk. This one is a work in progress, okay? So now we're in a different time frame, and we're talking about things that are evolving. So I am going to give you a snapshot of where we are today and expect this to change. This is part of the Valhalla project. The original problem we were trying to solve, there's a JEP 181, which is aligning the JVM checks with the Java language rules for nested classes. So Java has the concept of a nested class, and if you look in the language spec, there's rules for private members that talk about access is allowed if it occurs in the body of the top-level class that encloses the declaration. If you've read the JVMS, you've never heard of a top-level class. You don't know anything about enclosing classes, right? So we have a disconnect here, a friction point. So we want to solve that. We want to do a better job of making sure that they're in sync, and I'll show you the details of that. We also wanted to enhance access controls to better support other languages that care about them. And we want to evolve Unsafe.defineAnonymousClass to be a safe supported API. So what we found is we started to explore different possible solutions here for nested classes and for Unsafe.defineAnonymousClass. And then we discovered, as we came up with different concepts, some of these brilliant architects I work with came up with if we thought of something like nestmates, there's a whole bunch of other possible uses. So I'll describe to you what nestmates are, but we've discovered that there's some commonality, a common need for a concept, which is an access control context, which we might be able to use for sealed classes to only allow them to be extendable by nestmates. Value types in their boxes may have a tighter connection than regular classes or may not, implementation specific. Same with generic specialization, implementation specific, may or may not need this. Isolated methods may be able to take advantage of it. So the key message is we didn't just do this to solve a problem we've already solved in a not the best possible way, but solved. But adding them all together, we think this has multiple valuable applications. So I will give you the use case of the nested class today. So I said there's a disconnect between the language spec, which Java-C implements, and the JVMS spec. So today, if I have an outer class that has a private member, in this case a method, and an inner class that wants to call it. Sounds pretty simple, right? You do this all the time. Java-C under the covers is going to make this possible, okay? Because the implementation generates a class file, outer.class, and outer $inner.class. Well, now we're in two different class files, and from a JVM perspective, you're not related, right? You're just two different class files. So what Java-C does today is it creates a trampoline, it creates a static synthetic accessor, which calls Invokespecial. It's inside outer class, it calls Invokespecial on that method. It's inside the class, it's allowed to access the private method, you're happy. But you notice this is default access. So it's available to anyone in the package. So here we are, inside the inner class, which by definition is in the package, we call invoke static number 6, which is the accessor. And guess what? We've now been able to access it. Well, so is anybody else in the package, so we think that's a bit of a problem. Okay, here's the proposal. The proposal is a concept of nestmates. So we're looking at this as giving you an access control concept. So conceptually, nestmates derive from the same source file. There's a single author, single compilation unit. Implementation may just split them up. The goal is to have nestmates be able to access all members defined in the nest. So nestmates, I should have put it on here. The rules we're proposing is they have to be in the same runtime package, which means they're in the same runtime module. They need to be in the same protection domain. So you kind of got your public and your package and you're protected for free, right? You already have that. We are not changing any of that. But you did not have access to the private member that you were expecting to get to because it was in your source file, okay? So we're looking at expanding it to allow you to have private access if your author approves it. We also want, for dynamic languages and our own uses, classes to be able to statically or dynamically add to the nest. So the concept here is a class is completely contained in a nest, it's completely contained in a package, which is completely contained in a module, which is why this is one talk, even though it's a little long. So your next quiz will be on the access control changes that we're proposing for nestmates. The key message here is type access rules did not change. Sorry, there's supposed to be a space there. Member access for public, protected, and default did not change. What we're looking at is expanding the member access control rules for private as you can access by any class belonging to the same nest. The other note that's down below is there's two key points here. One is the owner says who's in their class, who the members of their nest are. And the other is that a class that does not declare belonging to a nest belongs to a nest with only its one member. So being, you are a member of your own nest. So this definition of a class belonging to the same nest includes yourself, right? Because we like the really clean concept stuff. Okay, you've seen this? I won't go over it. This is to show you the before. All we changed in the member access was the private, okay? So if S in package PS wants to access private member X declared in D, if S and D are in the same nest, i.e. nestmates, that's what we're proposing. That's the heart of the nestmates proposal. So it allows you to fix the nested class example I showed earlier. And in fact, it tightens the security for that example. So I know it's a little full, but this is, I hope, I made this up. So Maurizio, if this is not precisely what you're generating, this is close to what you should be generating. With nestmates, we don't need this accessor, okay? It's not necessary anymore. Outer $inner class is a nestmate of outer. And this guy, Java-C, behind the scenes, you do not have to, this will not change what the programmer sees, right? For most people, this will be transparent. Java-C will generate the information inside the class file that says, I am the nest owner, I am a nest member, and they have to agree. And what the bytecodes can do now is invoke special of M outer priv. And we will say, you are a nest member, this will work. So it actually tightens security because you don't actually have all the guys in the package able to get to this anymore, okay? So one other example, the Unsafe.defineAnonymousClass has multiple problems today. It's unsafe. It's not supported. You're not supposed to be using unsafe. It conflates capabilities. So let me tell you what some of those capabilities are. I am not saying this to encourage you to use it, okay? Do not, don't take away the wrong message here. It allows you to add a class into a host's package with access to the host's private members, okay? We call it a VM anonymous class. As we evolve, please find a new name. anonymous is overused, just bike shed. It is not findable, okay? This class cannot be found via class.for name, bytecode resolution. It's not in the loaded class cache. You define it, you get yourself a class, a Java-line class, you get yourself an instance, you pass it around. But nobody can go look it up. What does that mean? Well, it's temporary. The lifecycle is independent of the class loader lifecycle. We don't have to return it again. In fact, we won't return it to you at all. You can't find it. We can therefore unload it. Now, please don't make this a reason to start using it, okay? We really are going to get rid of it, so don't even go there, okay? It also allows this crazy addition of runtime types through patching the constant pool. You don't want to know what I think about that. Okay, exploring evolution, not based on unsafe. We are exploring. You'll see some of these on the Valhalla mailing alias. We're exploring, we'd love you to contribute. So in Java SE9, we added a lookup.define class with a byte array, which allows you to define a class in the same runtime package, module, and protection domain as your lookup class, okay? So that's been added. We are looking at the possibility of extending that by having a lookup. If you have a lookup with private mode, we could allow you to dynamically create nestmates. So remember I said that the author gives permission to be in the nest right now, and I'll go into the details of how that's in your class file. This is how you dynamically give permission, okay? We care deeply about security here. We know we are opening a little door, and we are containing that door. If you find a hole, let us know. We are totally aware of being careful about the boundaries. The lookup with private mode is how your author says you can dynamically add to the nest, okay? So we have a static mechanism and a dynamic nest mechanism, and the author is responsible for it. So we're not playing free-for-all here, okay? For not findable, we may change the API or add a Boolean, same with temporary, and we have we're exploring some alternatives to constant pool patching, so keep your eyes open. Detailed JVM requirements. Okay, so we mentioned that nestmates must be members of the same runtime package, runtime module, and share the same protection domain. We don't have nested nestmates. You belong to a single nest. The goal is to allow nestmates to access private members declared in the nest when the author allows it. We do not extend this to allow nestmates access to protected members inherited by a nestmate, which are declared in a different package. Not going there for 1,000 reasons. You don't even want to see the diagrams. There's no support planned for mixing Unsafe.defineAnonymousClass and nestmates. Don't even try it. I can't even draw the combinations. It's awful. And supporting static and dynamic nest additions. So these requirements should echo what we said was needed. Implementation changes required. Most of this is pretty straightforward, clear, and clean, okay? And this is where most people would say, yeah, just add nestmates, right? It's just easy. Most of it is clean. So for field access, get fields, get static, put field, put static. All we need are the access control changes, and it just magically falls out. And we like it when something is clean and just magically falls out. For methods, invoke static, invoke virtual, invoke interface, yes. Invoke special, darn. Okay, so this is the hard part where people can feel free to leave or doze. Actually, that's the invoke special, which is the next slide. First, I got to tell you, I talked about in the class file, we say, the author says, these are my nest members. So we're proposing adding 2 attributes, one of which says, these are my nest members, and you can bike shit on the name. As long as I can translate it, I don't care. The other says, I am the member of this nest. And guess what? Verification had better check that you agreed on that, right? We really do care about security deeply. We also ensure that you're a member of the same runtime package. And my favorite invoke special has some verification rules and bytecode special rules that we're going to go into in gory detail in case you like this kind of stuff. I do, but invoke special has 3 uses today: init, super, and local. And I managed to fit them all on one screen, which is maybe not a plus, but init example, we're all familiar with new dupe init, right? Using invoke special, that's pretty standard. I'm not going to talk about that anymore. It's not changing. Invokespecial is used for supercalls. So if I have class child with a parent, a direct superclass parent, I can call super.parents method, and I call it using invokespecial parents method, okay? Local example today. So if I have a private member, and inside this same class, I call, oh, did I do outer.private? Oh, sorry, I cut and pasted, my bad. Anyway, I can use invokespecial to get to the private member, right? And in fact, for private members in interfaces, invokespecial is the only way to get there, okay? So, the restrictions, the JVMS 9 invokespecial restrictions. So we're back to that same, I'm doing invokespecial on refc, so just to remind you the terminology. All invocation bytecodes have the restrictions that methods should only operate on subtypes, right? So that dynamic type is a subtype of the static type, right? Like virtual methods wouldn't work without that. But I like to be anal, so that's in here. We didn't change it. Invokespecial has additional restrictions. It is essentially a non-virtual call. So for superclass invocations, you're only allowed invocation on a direct superclass, okay? If you do the implementation, you know there's a corner case and we're not going there. And we'd like to get rid of it someday, but that's my wish list. But fundamentally, you can only call a direct superclass, which we translate as your class is authorized, you're allowed to do this. You're bounded in what you're allowed to do through this non-virtual backdoor. And you can only operate on objects that are yours. So the dynamic type has to be not only a subtype of the static type, but a subtype of yours. So if I am a bird, and I am inside, and my parent class is animal, I can operate on birds, I can operate on robins, I cannot operate on elephants, okay? So we try to bound this. We are letting you do a non-virtual supercall, and we bound who you can operate on, okay? So key thing is we are going to maintain those restrictions. So I tried to say the same thing for visuals in a chart. So it's the same thing. So if you're an auditory, you already heard it. If you're visual, let's see if this makes sense. S can call invokespecial on the static reference.x on dynamic receiver if, so in this super case, the restriction is that S has to be a subtype of refc, okay? And we talked, everybody says the receiver has to be a subtype of the static type, and we just talked about birds and animals, so receiver has to be a subtype of the caller. In the local case, this is sort of trivially true. Local means, because we implement this, right? So we care deeply that the caller is the same as both the, oops, wow, that was exciting. We were really done. The static reference and the defining class, right? Which basically means you have to be in the same class today, right? But that's what it means to us internally. And in that case, the restriction is the receiver is a subtype of the reference class because the others fall out for free. Now, what did we change? We actually worked, this proposal is in progress. What we worked very hard to do is to make sure that in the super case, the rules did not change. In the local case, the rules did not change. We have expanded what we mean by local, okay? So that's very intentional. And thanks to Dan Smith for the concepts, because I get into the details and he up-levels it, and I'm really grateful. So the point is, if you are a super and a nestmate, you follow the nestmate rules. But if you are a super, your rules are unchanged. You cannot, which fundamentally, since we're talking about restrictions, means you can't do anything you couldn't do before, right? That's our goal. We are not expanding what people can do beyond the explicitly authorized nestmate, where the author said, I will let you do this, okay? Nestmate open issues. So we are still sweating whether if you do an invokespecial on a private member and then you change that to be non-private, Should it still work, or should we say, I'm really sorry? And there's pros and cons, and I'm finding more pros and cons every person I talk to, so we will sweat that for a while. We are also working hard on, this is an implementation issue, minimizing additional class loading at verification, because that slows down all your class loading and your startup time. So we're being careful, we're checking the restrictions. We might have to evolve what is checked at verification time versus runtime. So something that is now a verify error may become a runtime error. And we are also being very careful with the order of checking subtype and nestmate, because we have to check whether you're in the super box or in the nestmate box without doing the class loading to find out if you're a nestmate. It's called magic. No, actually we're being really, really, really careful to close dot all the I's and cross the T's. The question I wanted to ask you is, how many of you currently use Unsafe.defineAnonymousClass? All right. All right. Well, it says I have 30 seconds left. Okay, my name's Karen Kinnear at oracle.com. I actually would like to know this. I really deeply, we want to make sure that as we evolve it, it meets your needs, okay? So if you would like to come to the workshop tomorrow, here we go. References. There's 2 workshops. I mentioned Alan Bateman's giving one on Jigsaw tomorrow. And I'm sorry, mine is on Wednesday. It's for Valhalla value types. If there's time, I would really love to hear about nestmate questions and Unsafe.defineAnonymousClass. If not, if you want to find me some other time, or email, or just find me in the hallway, we actually really deeply want to know. In fact, Paul Sandoz also wants to know, because he knows the Java side. I just do, the plumbing. How you're using Unsafe.defineAnonymousClass. 45, 44. Okay.